Okay. How do you solve problems when you have constant acceleration? Well, first, you have to read the problem carefully. Either the problem needs to indicate somehow that the acceleration is constant. Examples could be if it says it's free fall. So I suppose step one would be, is it constant acceleration? Well, you can look up, is it free fall? Because that tells you it's constant acceleration. Does it just come out and say constant acceleration? That actually happens a fair amount, believe it or not. Does it give acceleration as a singular value and indicate this is just what the acceleration is the whole time? So if it just says a is equal to some value, you could be pretty sure you're looking at a constant acceleration problem. All right, once you've identified that, pull out given quantities, make a list. You saw me do this with practice problems during class. I very carefully am listing out, here are the things that have all been given. Be careful to read critically. If you see, for instance, from rest, then you can immediately say v initial is 0, for instance. Vice versa. When it reaches highest point. So that would be a free fall type thing. But at the highest point, the speed of the object goes to 0. So that would actually be telling you that v is equal to 0. So be careful to read looking for things like that that give you a hint about initial velocity, initial positions, things like that. One other wording about position is frequently delta x is frequently the variable. Which is the reason why in a prior video I probably talked about how there are only so many quantities. Actually, I think I need to talk about it in this one. There are only so many quantities you're actually trying to look for. Acceleration, of course, time, velocity final, velocity initial, position final, and initial. But these two are frequently bundled together into delta x. So look for that. It makes it a little bit simpler because then there are only 5 variables to deal with. I probably do mention it when we're deriving the last 3 kinematic equations, so go back and watch that. But generally speaking, we have 5 kinematic equations because there are 5 variables that we can eliminate. We can either eliminate acceleration, eliminate time, eliminate final velocity, eliminate initial velocity, or eliminate our displacement. So keep an eye out for all of those. I strongly recommend drawing a picture. It helps me to visualize what's going on and sometimes to realize that I've been given more or perhaps less than I thought I had. Okay. Identify what you are trying to find. So that's an important step. If we have only really 5 variables and you've been given 4 of them and you're trying to find the 5th, that makes it very easy to figure out which kinematic equation is going to be relevant. So once you know what you've got, your givens, and what you're trying to find, try and find an equation that is only missing as a number what you want to find. And once you've done that, that's the right equation. There's only one unknown. You may or may not have heard this in your math classes yet, but you can only solve an equation for one unknown at a time. If you want to solve for 2 unknowns, you need 2 equations. If you want to solve for 3 unknowns, you need 3 equations. And that can turn into a system of 3 equations to try and solve. For this chapter, it's pretty much the case that you can always find one formula that pretty much has what you want, unless it's a problem with two moving objects, in which case you'll need two formulas and you'll have to find a way to relate them. One formula for each object and then relate through the conditions of the problem, like say collision, where they must have a common location at a common time. Alright, so once you've identified your equation, solve it. You should have your answer at that point. There were a number of examples during class. Go back and review those if you want any help on process, because I always kind of go through this process. You'll see me pull out the givens, you'll see me draw a picture, you'll see me identify what we're trying to find with a question mark. Then I'll talk about what equation we need to use, which one has only that thing as an unknown, and then we'll solve it. And I just realized I am hiding that last step. Fortunately, it's short. Alright. Remember, you can always contact me for help, so ask questions through Canvas Inbox or other tools, whatever we have available. I'll see you in the next video.